Good morning. Myself Bidarshan. I am from Srinivasa Ramanjana Institute of Technology from the Department of Electronics and Communication Engineering. Today's my topic name is Stability Analysis from Bode diagram. Stability Analysis from Bode diagram. Introduction to Bode diagram and stability. The Bode diagram is a graphical representation of a system's frequency response. The plot The plot both magnitude and phase versus frequencies on logarithmic scales. Understanding the Bode diagram is essential for analyzing system stability in control systems. Importance of stability in analysis. Stability analysis ensures that a system's output remains bounded within the time. It helps in designing controllers that prevent oscillators or divergence. Bode diagram into system. Bode diagrams provide valuable insights into system stability margins. Basic concepts of Bode plot. The Bode plot consists of two plots: magnitude versus frequency, and phase versus frequency. Magnitude is typically expressed in decibels, phase is expressed in degrees, indicating the phase shift introduced by the system. Basic concept of Bode plot. Bode plot. The Bode plot consists of two plots: magnitude versus frequency and base versus frequency. System transfer function and Bode diagram. The transfer function describes a system's input-output relationship in the frequency domain. The Bode plots are derived from the transfer function's frequency response. Analyzing the transfer function helps predict system stability using the Bode diagram. Gain margin and phase margin. Gain margin indicates how much the system gain can increase before becoming unstable. Phase margin measures how much phase lag can increase before reaching 180 degrees at the gain crossover frequency. Both margins are critically in assessing system robustness. Grain crossover frequency. The grain crossover frequency is whether the magnitude plot crosses zero. It is a key point for evaluating phase margin. The stability of the system depends on the phase margin at this frequency. Phase crossover frequency. The phase crossover frequency is where the phase plot crosses say 180 degrees. It helps identify the frequency at which the system may become unstable. The gain margin is evaluated at this frequency. Conditions for stability using Bode plot. The system is stable if the gain margin and phase margin are positive, where phase margin should be greater than zero for stability. The gain margin should also be positive to prevent instability. Nyquist stability criterion and Bode plot. The Nyquist criterion relates the where when loop transfer function to closed loop stability. Bode plot can be used to approximate the Nyquist plot. Ensuring that the phase margin and gain margin are adequate helps satisfy the Nyquist criteria. Interrupting the Bode diagram for stability. It look for the gain crossover point where magnitude crosses 0 dB. Check the phase at this frequency to determine the phase margin. Adequate phase margin indicates a stable system with robustness. Practical example: system with a single poles and zeros. A simple transfer function can be analyzed for stability using its Bode plot. The slope of the magnitude plot reveals the pole and zero locations. The phase plot indicates the phase shift introduced by these elements. Effects of pole on Bode plot and stability. Poles causes a decrease in magnitude and phase lag in Bode plot. Increasing poles can reduce phase margin and destabilize desta- potentially destabilize the system. Proper compensation can improve stability margins. Designing controllers for stability. Controllers like PID can modify the Bode plot to improve stability margins. Adjusting controller parameters shifts the gain crossover and phase crossover points. The proper design ensures positive gain and phase gain. Bode plot and phase margin specifications. Especially stable system has a phase margin at least 45 degrees. Increasing phase margin improves obstructions against disturbance. Bode plot adjustments that can optimize the phase margin. Limitations of Bode analysis. Bode analysis assumes linear time variant systems. In linearities or time delays can complicate stability predictions. Additional methods may be necessary for complex systems. Summary of stability analysis from Bode diagram. Diagrams provide visual insights to prove into systems stability margins. The margin and phase margin are are their parameters derived from the plot. Proper interruptions ensures robust and stable control system design. Practical tips for Bode plot analysis: always identify gain and phase crossover frequencies accurately. Calculate phase margin at the gain crossover frequency. Use Bode plot in conjunction with other stability criteria for comprehensive analysis. Conclusion and final remarks: Bode diagram analysis is a fundamental tool for stability assessments. Proper understanding of margins leads to better control system designs. Combining Bode analysis with other techniques enhances reliability. References and further reading: Kokata K. Modern Control System Engineering Person, Ruff R.C. and Bishop R.H. Modern Control System Person, Franklin J.F. Powell, J.D. and Imami Nain, a feedback control system and dynamic system persons. Thank you.